there without calculator. Now, I fully expect that you and I may have different standards for what's fair without a calculator, so I've been staring at logarithms on and off for over 25 years, 80 years, and you guys have not. So let's start with some simple ones.
If this is not easy for everybody, that's going to be mean.
What's x equal?
2.
Sam says 2. Do I hear another bid?
2.
2. All right, 2 it is. X equals 2. Did you calculate that using properties of logarithms, or
Yes.
did you just know it?
Properties of logarithm.
I think you just knew that one. So that's one fair one. Here's one that's a little bit trickier, and you may or may not know it.
Is that a 7?
Yes.
Okay.
Negative 1. 2. No, negative 2. Wow.
Go Dean. Okay, x equals negative 2. Why?
Because 7 squared is 49, so 7 is negative 2. 7 negative squared is 1 over 49.
Make the fraction. You guys are good.
You 1 over it.
X does equal negative 2. You 1 over it. Nabil is inventing verbs for us. I didn't say I didn't, enjoy inventing the occasional verb.
Sexually dominant math.
Okay, we'll stop that. Natural log of x minus natural log of 2 equals 0. Sam and Dean, hesitate. You got to count 5 Mississippi like a blitz. Come on, somebody else jump in.
X equals 2.
Pardon?
X equals 2.
X equals 2, that's correct. Take this another step. Natural log of x equals natural log of 2.
I have trouble with natural log.
So x equals 2.
Oh,
Well, actually, you're not
I didn't do it that way, but okay.
You're not even being asked to know anything about natural logs here. What you're being asked to do is compare two quantities and just figure an operation performed on x, if it equals an operation performed on 2.
Yeah, because
You can actually just take out the natural log.
In this case, yeah. Gentlemen,
in most cases, can you just take out the natural log and
yes.
figure that out?
In most cases, I don't know if most cases.
So how is that different than like basic?
Not in the last one. Because 250 minus 2 is not 125.
Okay. Yeah, that's actually right. In that case we just did with the log base 5 of 250 minus log base 5 of 2. That wouldn't work.
In fact, it only works.
The example we just did a minute ago was where if you have log base 5 of 250, now you weren't solving for x here, minus log base 5 of 2. Here you had to do the division first.
Yeah.
You couldn't take out the log base 5 in both cases.
Yeah.
In this case, it worked out that way, so you got to think about that a little bit. Now, let's get a little bit fancier. Now, some of these times, there's a couple of these you can do, and you can leave them in an interesting form. This is also fair without a calculator, but your book's direction on this one says to approximate 3 decimal places, but I might ask you to do something different with this one. 2 minus the natural, 6 times the natural log of 10 equals 10. Double check that.
Does that work?
Oh, I'm sorry, natural log of x.
Yeah, I was gonna say that.
There's no variable there. Thank you. Okay. So now what can I do to start getting x by itself?
Well, you do log 1.
Subtract the 2 from both
Subtract the
sides.
2. First subtract the 2 from both sides. This gives me negative 6 natural log of x equals 8. Now what can I do?
Natural log of x to the
Divide the negative 6.
I like Amy's idea better. I think it'll be simpler. She's going back to the algebra rules. So natural log of x equals 8 divided by negative 6, which is negative 1.25, I believe. Okay, now, so we're staring at this statement here, which I'll move up here. Natural log of x equals negative 1.25. How can you solve this?
It's actually 1 negative 1.33.
Pardon? No, you're right. You're right. I did my decimal wrong. Good catch. 3 repeating. I've been ill. Okay. Can we get x further by itself Without a calculator, do we absolutely need a calculator at this point?
We absolutely need a calculator.
No, this is fair without a calculator.
Maybe. I'm actually kind of curious about this one.
You
If
can
it's,
leave it like that.
what does a logarithm ask? What does a logarithm always ask?
What's the log base e?
X.
What's the exponent?
What's the exponent? How can you remember? Well, some of this is can you rearrange logarithmic and exponential expressions? What happens if you rewrite this? Well, first off, what's the understood base of a natural logarithm? E. So we're looking at log base e.
E to the negative 1.3.
So yeah, e to the negative 1.3 repeating equals x. Have we solved for x without a calculator?
Yeah. I mean, you can do it now.
Well, you can do it.
The short, yes, we have. Do we know what this actual value is? I don't.
X equals e to the negative 1.3.
And then because we don't like negative exponents in our answers, we would rewrite it as 1 over e to the positive 1.3
Yeah.
repeating. And I need to leave room for my fraction bar there, for my repeating bar. Okay, and that is my final answer. That is accurate. You have solved for x without a calculator. You don't need to do anything else.
That was fun.
But you got to know how to get from here to here. Okay, so this is a fair non-calculator question, but you got to leave your answer like that. I don't want anyone guessing what 2.718281828 to the negative 1.3 repeating is.
4, 8.
Is that really a guess? I'd be stunned if you were anywhere near right. That'd be fantastic. I would have you buy all my lottery tickets.
You buy lottery?
Yeah.
That means you are out.
I did like 3 times and I won $50 once, so I guess I came out ahead.
Did you know?
I worked at a place that sold them, so it was like the
Mr.
temptation
Belico,
was there.
Did you know that you're more likely to die driving on your way to buy a lottery ticket than you are to actually win the lottery?
That's a little bit of a scary calculation.
Probably true.
I have no doubt whatsoever that it is true. Not at all.
Ever come across that fact?
I have it on my
I
app.
read a lot.
iPhone app.
I have a fun fact on my app too, but like lottery.
That's a particularly interesting one. Okay, natural log of 4x equals 1. Now here, Amy's mad algebra instincts, which were so useful in the last one, aren't as useful because on this one, we had the 2 being added and the negative 6 being multiplied on the outside of the natural logarithm. Now all the interesting stuff is happening inside the logarithm.
Can we make it
Oh, yeah, sorry.
do something like
Can we do something?
No. Isabella, isn't it? Oh shit, it's whatever.
Oh.
Because it's 1. It's e to the 4x, and then you have 0 for x, 4 times 0 is 0. So then e equals 1. Or no, never mind.
Well, wait a minute. No, you're onto something here. So you're thinking, what you're thinking is make it log base e 4x equals 1, right?
Yeah.
And then the rearrangement of this is e to the first equals 4x, right? Is that correct?
What's e to the first is e.
E to the first is e. So e equals 4x. So what does x equal?
Oh wait, if e equals 4x, then
E's just a number.
then x equals e to the 4.
E divided by 4. You guys with me?
E4.
On that one? So Saul just did that faster than I was going to. I was going to do something like natural log of 4 plus natural log of x equals 1. Natural log of x equals 1 minus natural log of 4. Oh, this was going to be horrible. That's really what I was going to do. And then, oh, this is going to be great.
It's all smart though.
Check this out, what I was going to do next. Then I was going to do e to the natural log of x equals e to the 1 minus natural log of 4. Because remember how, this was the other next thing I was about to teach, or remind you guys, you know how when you have e raised to the natural log, they cancel out? Just like you have 10 raised to the log? Yeah, because if you have a logarithm in the exponent, it's the same base as your base of the whole exponent. So x equals e to the 1 minus natural log of 4. Now check this bit of craziness out.